an electronic mechanical heart is produced, with a motor in the middle driving 4 heart muscles in a cyclic motion through 4 connecting rods. Wrapped in a nearly new sock, it somewhat resembles a heart. The side view is passable, but the front view doesn't look as good. The internal structure is indeed not very reasonable and needs some modification. I reprinted the internal bracket, replacing the motor with servos. 1 servo is installed on each side below the heart, and only 1 servo is installed above the heart. Each of the 3 is responsible for its own area, making the movement less stiff. The V-shaped rocker arm is connected to the new internal support bracket, with a total of 2 sets. They are installed on the upper part of the main bracket. Then an inner lining bracket is installed. The servo drive board is placed in the middle, and small printed parts are used on both sides to secure it. Connect the wires properly. This backplate is used to secure the power interface and the speed control potentiometer is fixed to the structure with 3 screws. Install the development board to control the servo, with 1 arm and 2 connecting rods driving the upper internal support. Let's test it. Are all the servos adjusting speed normally? Yes, they are. This structure looks much more sophisticated than the initial one. The internal components are sorted. The 3D printed myocardium shell consists of a total of 5 pieces. 1 large piece on top and 4 slightly smaller pieces at the bottom. How's the effect? The movement method is clearly more reasonable than before. Comparing it naively, it's still a bit lacking. Adjust the code, use phase functions to handle signals, and adjust the cycle time with a potentiometer to achieve slow expansion and quick contraction. Once installed with the casing removed, it indeed became more impressive and agile, expanding slowly and contracting quickly just like a real heart. From this angle, it looks like Wally's girlfriend Eve, and it does look quite nice. Now, it just needs a cover. I printed a model of the same size to facilitate mold making. Preparing the sculpting clay, it doesn't matter if it gets a bit messy, just grab a bit and cover the whole thing with a layer, then continue to stack and mold the specific shape of the new machine. Add veins and arteries, and try to carve out the details. Use a ribbon tool to scrape out the myocardial texture, making it look more realistic. Finally, adding the coronary vessels makes it look exactly the same. Fix it onto a wooden block. Then prepare a bowl of silicone, and slowly brush it onto the surface of the model. Be a bit meticulous, and make sure to cover all the nooks and crannies. This way you can completely preserve the details. Now you can mix a bit more. Place the model properly. Pour all the silicone in, and once it sets, pull the model out. Then clean the inside thoroughly with soapy water. Pick up the missile demolding tool and give it a shake to ensure everything is in place. Mix the dark red silicone, pour it into the mold first, then insert the model with the clay removed, press it down. Oh dear. A lot came out. Added a bit too much, but it's not a big issue. Leave it for now, and remove the model after it dries. Slowly pull out the heart casing as well. Try using soapy water to give it a slight clean. There are still some mold residues on the surface. Clean them all off thoroughly. Now putting the silicone casing on the electronic heart makes it look very realistic. Wow, see how it looks even more real when it moves. Apply a darker shade to the myocardium, then spray a bit of cream color to create the fat layer. I sprayed too much here, so I'll wipe it a bit. Even without movement, it already looks very realistic, and when it moves, it's even more incredible. See how the adjusted heart is held in the palm? The feeling is just so powerful. An electronic mechanical heart is now complete. As long as it's plugged in, it can keep beating like this.